All right, today we're going to do lesson 6.2, substitution. And today, here's all we're going to do. We're going to solve systems of equations. Forgot an S there, sorry. Systems of equations by using substitution. And what does the word substitution mean in math?
Subtracted. No. You exchange it.
You exchange. You replace something. What did you say?
Put it in its place.
Put it in its place. Okay, so there's something that's very, very important about the two things that you're substituting. What do they have to be? If you're going to substitute one, yes, if you're going to substitute one quantity in for another quantity, they have to be equal. Okay, I don't get to just pick up something out of an equation and replace it with something I like better. I have to replace it with something that is equal. Okay, and so substitution is all about finding something that's equal to another thing and then replacing it. Okay, and that's what we're going to do today with the lesson. We're going to start out just like we've been doing, just like we started with yesterday, a system of equations, two equations that use the same variables. We're going to use substitution to solve the system of equations. What I want to do at this point is find something that I can substitute in one of these equations. And I see right off the bat here that I've got a y equals the quantity 2x plus 1. So I know what y equals. Even though I don't know a number that it equals, I know a quantity that it equals. And so when I see a y in this equation, what can I do here? Substitute 2x plus 1. That's right. This y is the same as this y, and I know that y equals 2x plus 1. So wherever I see y's at, I can put 2x plus 1. So all I have to do is substitute this quantity for this y. All right, so we'll just do that. 3x plus 2x plus 1 equals negative 9. And now just solve for x. So 3x plus 2x is 5x plus 1 equals negative 9. So this is minus 1. 5x equals negative 10. So x is negative 2. Now am I done?
No.
What else do I need to do now?
Figure x out.
Yeah, well, I know what x is, but now what do I need to do?
Substitute.
Yeah, substitute x into either one of these equations. Doesn't matter which one, whichever one looks easiest. Right? So I think the top one looks easiest here, so I'm going to do that. And I'll switch colors here. How's that? Y equals 2 times negative 2 plus 1. So y equals negative 4 plus 1, which means y equals negative 3. Okay. Now, if I've got an x value and a y value as my two solutions here, how do you think I ought to write those?
Slope-intercept. That's completely wrong.
Not slope-intercept form. It's not a bad thought. How do you see an x and a y written together?
In the parentheses.
In the parentheses. What do you call that?
The point slope.
Ordered
Ordered
pair. All right. So negative 2 comma negative 3
I do that.
is my ordered pair, right? Okay, now, you're not going to have to do this today. You're not going to have to do any graphing today. All today is about using substitution to solve. But I'm going to go ahead and graph these two equations just to make a connection for you to what we did yesterday. So I didn't even give you this slide. Our ordered pair, remember, is negative 2, negative 3, right? So negative 2, negative 3 is the ordered pair. So let's graph these. I can graph this first one real easy. 2x plus 1, there's plus 1 up to over 1. So this is my line for the first equation. Like, man, I'm having trouble seeing from back here. About right there. That's pretty close. Okay. Now I'm going to switch colors. And to graph this one, I just need to get it slope-intercept form, right? So y equals negative 3x minus 9. So minus 9 would be right here. Up 3 over 1, up 3 over 1. Okay, now where do those two lines intersect? What's the ordered pair? It's -2 if you go over 2 and then down 3. My lines are pretty close. It's an error in my lines, not in the math of what we've done here in the graph, if it's not perfect. But -2, -3, we've been calling this the solution to the graph, right? And so what it turns out is this ordered pair is the only x and y value, only x and y combination that will solve both equations. Does that make sense? And so now we have two ways of solving a system of equations. We can graph them and find where they connect, where they intersect, and that ordered pair is our solution, or we can use substitution to find the ordered pair. And both of them should get us the same answer. Okay? That's the whole point of what we're doing here. So, I've just got a few examples to work through. We're going to substitute, see some different types of substitution we can do, and then you've got an assignment.
Okay.
So what am I going to do here to substitute?
Substitute the y in the 4x minus 6.
Okay, so where I see a y in this equation, I can substitute 4x minus 6. 5x plus 3 times 4x minus 6 equals -1. 5x plus 12x minus 18 equals -1. Add 18. So 17x equals 17. That leaves us with x equals 1. There's our first part of our solution. Now I can substitute 1 into either one of these equations for x. I'm going to substitute it right there. So y equals 4 times 1 minus 6. Y equals -2. Don't forget to write it as an ordered pair. Okay? All right, so y equals 3x plus 10. I can substitute this value right here in for y. So 2x plus 5 times 3x plus 10 equals -1. $50 equals -1. So 17x plus 50 equals -1. Subtract 50. 17x equals -49. No. Wow. Sorry. Equals -51. Divided by 17, so x is -3. Now I can take -3 and substitute it into this equation for x. Y equals 3 times -3 plus 10. Y equals -9 plus 10, that is 1. So -3, 1. All right, this isn't too bad, is it?
No.
I mean, it's a lot of steps. You got to do a lot of solving, but it's pretty straightforward. Sometimes you got to do a little bit of work before you know what to substitute. So I don't have anything that equals one of the variables by itself, so I need to do a step before I can do that. This first equation, I would be able to get x by itself really easy, wouldn't I? And so I don't have to solve for y. I don't have to use y first. I could use x. So if I do x plus 2y equals 6, and just subtract 2y, now I know what x equals. X equals negative 2y plus 6. So now I can substitute in x into the other equation and solve for y to begin with. So I would have 3 times negative 2y plus 6 minus 4y equals 28. Negative 6y plus 18 minus 4y equals 28. So I can do this, subtract 18 from both sides. And what's negative 6 minus 6y minus 4y? Negative 10y equals 28 minus 18 is 10. So y equals negative 1. Now I can substitute negative 1 into this first equation. So x plus 2 times negative 1 equals 6. X plus, or actually x minus 2 equals 6. So x equals 8. Eight negative 1 is my ordered pair. Did I write the ordered pair last time? I didn't. Yeah, I did. All right. Last example. I can get y by itself real easy right here. So add 3x. Y equals 3x plus, no, minus, sorry, minus 13. Minus 13. So 3x minus 13 will go in for this y. 4x plus 5 times 3x minus 13 equals 11. Oops, I forgot a 1 there. 4x plus 15x. And then 5 times minus 13 would be minus 65 equals 11. Add 65. So that would be 19x equals 76. Divided by 19 is x 4?
Yeah.
Okay, so x is 4. So I can substitute 4 into either equation. This one looks pretty easy. Y minus 3 times 4 equals negative 13. So y minus 12 equals negative 13. Add 12 and y is negative 1. So 4 negative 1. All right. That's pretty much it. Substitution to solve equations today is what we're doing. I've got a skills practice worksheet. It's got 20 systems on it. You can choose any 10 problems. I don't care what 10 you choose, your choice. And that's your assignment.
If we do all 20, is that extra credit?
I will give extra credit if you do all 20.